we're going to use excess reaction. Just let me spell this and I'll get on with it again. Reactant. Remember, reactants are the beginning of a reaction, the starting materials. So one of them is left over and the other one that ran out first. So we used it all up. So we call this one limiting reactant. This one controls the reaction. So we'll write it here, controls it controls the reaction. And what I mean by saying that is that this tells us how much of the products we'll get. Whichever one is limiting basically sets the ratios for the two products or more products. Whatever products we happen to have, the limiting reactant tells us how much we're going to get. It doesn't really matter how much of the excess we have because we'll have some left over. We won't use it all up. But the one we use up is the one that will control how much we get. So that's the one we're going to use to do our mole ratio or other calculations to figure out what the products are going to be. So let's do basically the whole first page here is a reaction example. So let me write in the reaction. If we get nitrogen gas and hydrogen gas to produce ammonia, we've done this reaction a few times. It is nitrogen gas N2 plus hydrogen gas H2 makes ammonia, which is NH3. So that's our starting point. The next step we have to do, as always, is balance the reaction. To balance, I need my ammonias to double to get my nitrogen set, and I need 3 sets of the hydrogen gas and 1 set of the nitrogen gas. So this is now my balanced reaction. So basically what we're going to do is go through a process to determine, given these starting conditions, which one is going to run out first, basically. So first thing we do is we choose a product. And that's usually the one given in the reaction to figure out how we're going to do it. So in this case, there's only one. So it's going to be the NH3. So our product that we're going to be testing is the NH3. It's very boring. So we have to test each reactant, as if they were limiting. Each reactant as if they were limiting. So we're going to do 2 different mole ratio calculations to try to figure out which one got used up first. So given my starting points that I have 56 grams of nitrogen gas and 15 grams of hydrogen gas, those are the 2 we're going to test. First line, we're going to test nitrogen. So we start with how much nitrogen we have. In this case, we have 56.0 grams of nitrogen gas. N2. That's what we start with. Now, to get how much NH3 we're going to predict to be made is we're going to look at changing all of our mole ratios into the ammonia step. So we have to get mole ratios. So first step is a molar mass step. In this, we need grams per mole. Grams per mole of nitrogen is 28. Nitrogen gas is 28 because it's two 14s. And that's per 1 mole. Then we're going to do our mole ratios to ammonia, 1 to 2, mole N2, mole NH3. This fraction is right from our balanced chemical reaction. So this one is coming from these guys. Right, that's where those numbers come from. And then we got to figure out how much NH3 we're going to get. So the next fraction is the grams per mole of NH3. NH3 isn't that bad to do because it's a nitrogen, 14 plus 3 hydrogens is 17. So 17. No need to get our calculators out too hard on these ones. But now we will need to get our calculators out to do this math. So let's multiply and divide as we need to figure out how many grams of NH3 we're going to get. I need my calculator. All right, after all the calculator nonsense, we get 68.0 grams NH3. So we're going to do the same calculations starting with hydrogen. We have 15 grams of the hydrogen gas. So starting with 15 grams of H2. And we're going to multiply that by my grams per mole of H2, which is pretty easy to count. What's the molar mass of H2? 2 grams per 1 mole H2. And then we will multiply by my molar ratio, which looks like I'm going to get 2 to 3 in this case. Mole NH3 and mole of H2. Do another circle here, but I'm going to change the colors for my notes. Circle that one, and it's that one, and that one. That's going to look silly on the screen, but we'll be okay. It's not terrible. All right, the ending step is exactly the same as it is above because it's the same process. We're multiplying by 17.0 grams per 1 mole. And this is NH3 at the end. So now, once again, that's calculator time. 15 divided by 2 times 2 divided by 3 times 17. 85. All right. So these are my two predictions, only one of which can actually be true. Which one do you think is going to be the limiting reagent? Well, no, it's two. It's N or H. Oh, sorry, yeah, it's nitrogen or hydrogen. Why nitrogen? Because of the smaller number. So that's the right answer. Smaller number will be the limiting reagent. So, in this case, N2. So N2 is my limiting reagent at this time. So N2 will run out first, and so H2 will be in excess. Left over. So at the end of this reaction, as stated in the prompt, if that's what we started with, we'll have extra hydrogen gas left over with our ammonia gas. All the nitrogen gas will go away. All of it will react. There will be some of the hydrogen gas left over. And so my main prediction for this reaction will be that 68 grams of ammonia are produced. I won't get 85. It'll run out before I get to 85. So I'll get the 68 grams, as I point out here. We'll get this much. We won't get this much. We'll run out first. So that's why we take the smaller one. All right. Example 2, we're going to have magnesium and oxygen reacting. We know we have 21 grams of oxygen, and we've got to figure out how much, which will run out first. So first thing we got to do is balance our reaction. Always have to start with a balanced reaction. We should never assume it's balanced. Always check. So balancing this one, I'm going to need 2 there, then 2 there, and I think that's done. So we have this ratio to start with. So to find out which one's limiting, we have to do both of my reactants to try to make how much magnesium is going to be produced. How much magnesium oxide will be produced. So let's just start with one magnesium, and then we'll do the oxygen below. So same as we did before, 2 sets of these calculations. Start with magnesium, and we will do 15.0 grams of the magnesium. We're going to look at our periodic table to figure out what does a magnesium weigh. I think a magnesium weighs 24.3. Do we agree? Those of you that checked? All right. Then we do our mole ratio step. Magnesium is going to be on the bottom. And the one I'm going for is magnesium oxide on the top. So both of them are 2s, so it's kind of a boring, useless step. We can skip this step when we're doing our calculator bit because that's just a 1. But we write it down to show that we understand what it's doing. Next step, same as it is before. You guys are going to see these same processes all the time. Divide by the first molar mass and times by the second molar mass. So how many grams is a magnesium oxide? 24.3 plus 16 should be 40.3. 40.3 grams per 1 mole of my magnesium oxide. And we'll get our mass done here. So let's do a quick math. 15 divided by 24.3 times 40.3, 2487. 24.8765. That's so many significant digits. That's plenty. But we might need to check many decimals down, but probably not. We're going to do exactly the same steps, but starting with our oxygen mass. So we're getting really comfortable with this kind of math layout. It's going to start becoming tedious. So next one is our oxygen setup. Is 21 grams of the oxygen. Now, don't forget, a mole of oxygen is O2, so it weighs 32 grams, right? O2 is 32 grams. Same ratio time. We're going to go 1 mole of the oxygen on the bottom and 2 moles of the magnesium oxide on the top. So I got a 2-to-1 ratio here, and the last ending bit of the fraction is the same because it's magnesium oxide. It didn't change from one fraction to the next. So that's my fraction layout, and now I can do my calculator steps. 21 divided by 32 times 2 times 40.3. And I get 52.893. That's plenty of digits. There's more, but I don't need them. All right. So, which one is the winner? Which one is limiting? Yeah. So, the magnesium is the limiting one because it's smaller. So, this one is the smaller one. Let's change colors on that. It's really hard to see. Yeah, maybe that one. Slide it up a bit. Sure. Then we'll write our answer. So, Mg is limiting. And 24, right number, significant digits, 0.9 grams of MgO are produced. I don't know if that's grammar right, but the numbers are right. So we got 24.9 because we have to round it to our 3 significant digits from the question. All right, how much oxygen is left over? So we got to look for the mass of oxygen left over. So we're going to use, I'm going to write it in here as an instruction, use starting magnesium mass to find O2. basically, if we use up all the magnesium, how much of the oxygen did we use up, and then subtract. So we're going to do the mole ratio calculation to try to look for how much oxygen would be in balance with my reaction. So starting with the same part that we did over here, we'll basically start with this, but we're going to finish with oxygen. So starting here the same as we did before, but we're going to finish with the oxygen on this side. So starting with 15.0 grams magnesium multiplied by the mass, 24.3 grams for 1 mole of magnesium. Then we'll do our ratio step, which will be 2 mgs and 1 mole, O2. That's not very nice. Let me clean that up a bit on the bottom. It's a mole, so let's just do that. Mole mg. That's better. That looks better. And then at the end, we're going to use the 32 grams to figure out our mass of oxygen. And we can get how many grams of oxygen we expect to use up. So let's do a little bit of math. 15 times, divided by 24.3 equals, divided by 2 times 32. 987. So we're going to get 9.8765. Wow, that's kind of fun. That's 987654321 is the decimal you get out of that. That's crazy. I'm sure that's important for some reason. What we can do, our subtraction now. So the subtraction is we started with 21.0 grams, and we used up 9.876, bunch of numbers, grams. And so we have, to the right number of digits, 11.1 grams O2 left over. So that's how many grams of oxygen are left over. We used up 9.865, and we have 11.1 left over. Rounded to the right number of significant digits for our end of the calculation. Record. So at the bottom of this page, as I slowly slow down, I have the questions I have asked you to do. The percent yield questions are from lesson 4, and it shows that I counted better. There's some on there that I told you in the last class that you should do. It shows you which ones to skip right in there. So if you didn't start Friday's lesson, that makes sense. Anyways, you can do, this is the one from Friday's lesson. So that's from Friday's lesson 4.